Okay, so here in section 4.3, we begin by leaving the unit circle. And when we leave the unit circle, the radius is now of a circle is maybe not 1 anymore. Looking here at the cosine of theta being 3/5, we find that cosine is the x over the r piece. So the x component is 3 and the r is 5. And if we think about a triangle here, a right triangle here, where the x piece is the horizontal piece 3 and the r piece is the hypotenuse, the radius piece is 5, we would be missing the y piece, and we want to find that y piece first. So we'll use the Pythagorean theorem, a squared plus b squared equals c squared, and the only concern in using the Pythagorean theorem is that c is always the longest side. So what I know right now for sure is that the 5 squared is c squared. A and b really can be interchanged, so I'm going to say a is 3 squared, and then b is something I don't know, so we'll just say b squared. So 3 squared is 9. Let me erase that. Okay, 9. And 5 squared is 25, so we'll subtract. B squared is 16, and we'll square root to get side B to be 4. So this missing side of this triangle is 4. Now once you have this triangle completed, that is a huge step, because now the questions are dealing with what the tangent of the angle is, tangent of theta. Well, tangent wants you to take the y piece and put it over the x piece. And so simply the y piece is 4 and the x piece is 3, and we are done finding the tangent. Cosecant is the flip of y, and so, or the flip of y over r, so it'd be r over y. And so it is the 5, which is the r, on top of the 4, which is the y, and 5/4 would be the cosecant of theta. We'll let you work on 2 and 3 and see how you can do there. Okay, moving on to 5 through 8 in these problems, we are wanting the sine of pi over 3, and from what we've done in class, when you see the angle is pi over 3, you should be thinking about an x-coordinate that is 1/2 and the y-coordinate that is the square root of 3 over 2. Those are always seen together, and you always want to put the one in the x spot that matches the 3. So it is 1 and 2 that makes 3. That keeps you from wanting to put the square root of 3 over 2 here in this x spot. So once you have the ordered pair in the correct order, the sign is just wanting the y of that ordered pair, so the y-coordinate is the square root of 3 over 2. I'll let you go ahead and try and find the tangent of pi over 6, the cosecant of pi over 3, and the cosine of pi over 4. Okay, the next section here, going from 9 to 13, we want to find the tangent of 65.7. Well, if to do so, you know tangent wants you to put the y on top of the x, but I bet we don't have memorized whatever this x is and this y is for this particular angle. If you don't, you're just like me, because I don't either. But what we can do is grab the calculator and punch in the calculator the tangent of 65.7. But before you start punching buttons on your calculator, please make sure you notice right here that the angle is degrees, and so therefore we need to have the calculator set in degree mode before we punch in the tangent of 65.7. When I enter the tangent of 65.7, I get 2.21475, blah, 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 so on and so forth. We're supposed to round the answer to 4 decimal places. So what I'm going to look at is this is the first, second, third, and fourth decimal. I have to look at the 5th decimal to decide if that goes up or down. Since it rounds up being 5 or more, it would be 2.2148. That is the tangent of 65.7 degrees. Okay, the next one is the cosecant of 24.94 degrees. Well, if you look at your calculator, you do not have a cosecant button. Okay, so there's no cosecant button. So what we're going to have to do is we're going to have to press the sine button and find the sine of 24.94 degrees. And if we do that, that is 0.421669, so on and so forth. However, we really didn't want the sine, we wanted the cosecant. And so cosecant's relationship to sine is it's a flip. So we need to take this decimal and somehow flip it, and the way to do that is to take 1 and divide it by that decimal. So if you're familiar with the answer key on your keyboard, it's second negative on my calculator, but if I do 1 divided by second answer, then it turns that into what the cosecant is of 2.3715. So let's review that. How do we find the cosecant of some decimal we don't know the ordered pair to? We treat it like it's the sine of that angle, and then once we have the sine of that angle, we flip it so that it is the cosecant. Okay, I'm jumping down here to number 12 right here, and the reason I'm taking that jump is it says the secant of 5 pi over 7, so you might be ready to press the buttons on the calculator and say cosine of 5 pi over 7. And that's all good, but 5 pi over 7 is not in degrees. If you notice, there is no degree symbol here, so this angle is radians. So my calculator must be switched to radian mode, and then I can do the cosine of 5 pi divided by 7. And that gives me a decimal of negative 0.62348, and so on. And I don't want the cosine. That's what this is the cosine. I wanted the secant. So to flip that, we just do 1 divided by answer. 1 divided by answer, or you could retype it all if you were so choosing to do so, but 1 divided by answer will flip it. And that, rounded to 4 decimal places, is negative 1.6039. Okay, I'm going to move to the next section here, 14, 15, and 16, and try and make sense out of what it's asking us to do. If you remember, we learned that cosine of some angle is the x piece over the r piece. And so if we are told what that x piece over r piece is, it's this decimal. We are questioning what angle causes that to happen. If you notice my direction of travel, I know the cosine but want to come back and know the angle. It's almost a backwards from reading from left to right. It's backwards. And so if we think about that, the operation that brings us backwards to an angle is the inverse cosine of 0.5692. Now you do need to be in degrees, otherwise it's going to give us our answer in a radian measure. So we want to set the calculator in degrees, and then second cosine 0.5692, and that is 55 degrees. So on 15 you'd want to inverse sine, and on 16 you'd want to inverse tangent. Okay, moving down to 17 in this section, it says find the value of theta in radians in terms of pi. Well, if you're in trig, you can translate this backwards. This is saying basically the x is 1/2. And so if I think of an ordered pair here, it is the x that is 1/2. As soon as you know the x is 1/2, it's always seen together with the square root of 3 over 2. The fact that the x tells you the angle, what we can say is because this x is 1/2, I know the angle is pi over 3. Because remember how we had that memorization technique, what makes thirds is 1 and 2. So in this light, we want to get to having the x-coordinate, and once we know the x-coordinate, that will lead us in thought to the angle. Okay, let's try this out on 18. This translates in plain English to y is the square root of 2 over 2. So if I'm thinking about this, the y is the square root of 2 over 2. What is always seen with the square root of 2 over 2 is the square root of 2 over 2. Based off this x-coordinate, what is the angle? Pi over 4. Okay, now 19 looks really kind of strange and probably foreign, but if you think about 19 for a second in terms of what it is instead of the flip, okay, cosecant is the flip of sine. So if I say sine instead of cosecant, I would say 1/2 instead of 2. So now the fact that the sine is 1/2 means the y is 1/2. If the y is 1/2, the partner with it is always the square root of 3 over 2. And based off of this x always, the angle would have to be pi over 6 that had that be the x-coordinate. So what do we take the sine of to get 1/2? What do we take the sine of to get 1/2? Is pi over 6. Okay, I've really blown up 20 here for a reason. Tangent is sometimes tricky to kind of understand. Tangent is y over x. And so when I just see plain old square root of 3, that's got to be over 1. And so if I'm thinking about the ordered pair here, the y part is the square root of 3. The x part is 1. Now, this is a magic show, but I will clarify this a little bit here in a second. But if I put the number 2 under both of these, notice these are the recognizable ordered pair that we've kind of memorized. So now, based off of this x 1/2, what is the angle that 1/2 matches with? Is pi over 3. Okay, 1 and 2 makes 3. Now, why does the magic work where I can just sneak a 2 in there and make that happen? I'll show you, but never require you to do this, so just kind of follow along and hopefully it makes sense. If we draw a right triangle and we make the y piece be the square root of 3 and the x piece be 1, we are going to complete that triangle with the Pythagorean theorem to find the missing side. So the square root of 3 squared plus 1 squared equals c squared. So the square root of 3 is 3 plus 1 equals c squared. So c squared is equal to 4. The square root of 4 is 2. So this missing side up here, right here, is 2. Now that's not a unit circle. So if I wanted it to be a unit circle, I would divide everything by 2, and voila, 2 divided by 2 is back to a 1 unit circle, and magically the ordered pair we have memorized shows up so that we realize that's why we could put the 2 underneath. It works, but it's kind of a magic show if you don't understand why it works. So we'll probably see that more as time goes on and get a little more comfortable with it as time goes on. Okay, and finally, number 21 here. Once again, when we speak about secant, I probably don't understand secant as well as I do cosine, so I'm just going to rewrite secant as cosine, but then I have to realize that it is the flip of what I had. So I have to flip those over, use the reciprocal of those numbers that I had before. So now I can rationalize this. Square root of 3 meets the square root of 3 here and becomes 3 times a 2 is a 6 for a denominator. 3/6 reduces to 1/2. And so ultimately, we may not have recognized it at the beginning, but the cosine of theta is actually the square root of 3 over 2, which means the x-coordinate is the square root of 3 over 2, which means the y-coordinate is 1/2. But the angle we are searching for on these is always based off the x-coordinate. So the angle we're searching for is pi over 6.